today I discuss about the approximate methods used for the analysis of the multi-story frame buildings subjected to horizontal forces. Approximate methods for the analysis of multi-story frame building subjected to horizontal forces. There are three methods for the analysis of multi-story frame building. They are listed here. First, portal method. Second one, cantilever method. Third one, factor method. Right? These three specific methods used for the analysis of multi-story frame building. These two methods apply for the multi-story frame building. They have same moment of inertia for the columns and beam. But the third method is best, accurate and precise method for the analysis of the multi-story frame building, which having the moment of inertia for all the columns which may be equal or not equal. Now, first of all, I introduce about the portal method. Portal method. I take a two-story frame building subjected to horizontal force. These are 1 and 2, windward direction to horizontal force P1 and P2, and in x direction 3 bays 1, 2 and 3, they having length L1, L2 and L3, and the height of these three buildings, H1 and S2, right? A, B, C, D, E, F, G, H, I, J, K, L. This is the multi-story frame building. Now we want to analyze this multi-story frame. In the portal method, there are two assumptions made for the analysis. First assumption and second assumption. Two assumptions made in the analysis of portal story. First assumption is that the point of contraflexure exists at the middle of the column. And first assumption is that point of contraflexure exists at the middle of the columns. And second assumption is that the horizontal shear or horizontal force is shared by the horizontal shear assumed to be P1, P, 2P, 2P and P. We take twice of P in all the internal columns and single in the outer column, or P in the outer column. And for the bottom story, R, similarly 2R, 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 middle, and second one, the horizontal force is equally shared or shared by the all the horizontal forces. P or horizontal shear, P 2P 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 2P, right? Now for the determination of these horizontal shear, first of all, P plus 2P plus 2P plus P, P plus 2P plus 2P plus P, these 6P internal forces or reaction forces balance the force externally acting at point A, that is called P1. This implies 6P is equals to P1, then P is equals to P1 upon 6. In such a way that we can calculate P by using P1, and 2R, R, 2R, 2R and R, they balance P1 and P2 at the bottom level. Now R plus 2R plus 2R plus R is equals to P1 plus P2. Both P1 and P2 balanced by R. Now 6R is equals to P1 plus P2. This implies R is equals to P1 plus P2 upon 6. Right? फर्स्ट स्टेप तो हमारा ये है, सबसे पहले हम क्या करेंगे कि जो हमारे जो मल्टी स्टोरी पे बिल्डिंग दिया हुआ हो सकता है ऊपर भी थर्ड स्टोरी फोर्थ स्टोरी और हो, इधर भी थर्ड फोर्थ पे और हो। सिमिलरली हम लोग P Q R अज्यूम करेंगे हॉरिजॉन्टल शियर, और इस डायरेक्शन में हम जो भी हमारे पास लेंथ होगी L1 L2 L3 लेंगे, इस तरीके से हमारा ये डिस्क्रिप्शन होगा। तो हमें सबसे पहले हॉरिजॉन्टल शियर कैलकुलेट करना है। Next step, in the next step, we take first step number 1 for the analysis, and step 2. In this step 2, we calculate or we determine the moment at the end of the column. Now, bending moment at the end of the columns, right? Columns for first story and for second story. For first story, P into h by 2, that is called bending moment at the end of this column. 2P into h by 2, 2P into h by 2, P into h by 2, right? For first story, for top story, for top story, P into h by 2 and 2P into h by 2. P into h by 2 for first and last column, and 2P into h by 2 for middle two columns. For bottom story, R into h by 2, 2R into h by 2, 2R into h by 2, R into h by 2, means R into h by 2 and h1. This h means that h1, that h means that h2 and 2R into h2 by 2. In such a way, we calculate bending moment at the end of the columns. Now, step number 3 is called bending moment at the end of the beam. Step 3, bending moment at the end of the beams. Beam 1, 2, 3, 4, 5, 6. Now for top story, moment M AB is equals to M, BA is equals to M, BC is equals to M, CB is equals to M, CD is equals to M, DC is equals to P into H1 by 2 only. Now for bottom story moment M E F is equals to M F E is equals to M E F if Z H equals to M H G is equals to 1 EF FE FG M F G and M G F is equals to, देखिए इस कॉलम के एंड पे हमें मोमेंट चाहिए यहाँ पर, तो हम बात करेंगे P into H/2 in the clockwise direction, and next again R into this H/2 gives again in clockwise direction. That is why P into H1/2 plus R into S2/2, but H1 is equals to S2 is equals to S, then we can say P plus R into H/2. Now step number 3 is finished. Now step number 4, to calculate shear. Step number 4, to calculate shear in the beams. Calculate shear in the beams. Shear in the beams. Shear in the beams, calculate shear in the beams, right? For first of all, for the top story for top story building, F AB is equals to MAB plus MBA upon L, means sum of the moment at the end of the beam divided by length of the member. Next L1. Next F BC is equals to MBC plus MCB upon L2, and MDC FCD is equals to MCD plus MDC upon L3. Likewise, next for bottom story. For the bottom story, FEF is equals to, these all are the shear in the beams. FEF is equals to MEF plus MFE, MEF plus MFE upon length L1, length of the member. Next shear FG is equals to MFG plus MZF upon L2, and lastly FGH is equals to MGH plus MHG upon L3. Right? In such a way, we can calculate shear in all the beams.